Hello and welcome to part 2 of my self-designed audio amplifier circuit. You have to watch part 1 first because now I'm explaining an improvement of the circuit, so if you don't have watched part 1 first, then you maybe have some understanding problems. So, okay. The improvement is a bridged version of this amplifier. Bridged version means that I build two amplifiers and they are working together as one amplifier, and with this I can get much more power. Here's an example of this for better understanding. Okay, here I have two amplifiers connected to the supply voltage and to ground. If I'm using one amplifier, I don't think of this, and the loudspeaker is connected here to ground, and I have here an output capacitor if I use just one amplifier. And if I use one amplifier, I can pull the wave up to the supply voltage half, because I have ground here and the amplifier needs for the coming up wave the half of the supply voltage, and for the down side it needs also the half of the supply voltage. So with this equation here, focus a bit, yes, with this equation I can calculate the maximum current through the loudspeaker with just one amplifier, which the supply voltage and ground. The maximum current through the amplifier is the half of the supply voltage minus the voltage that the amplifier needs, for example the losses of the transistors. So this is about 1 volt, so half of the supply voltage minus 1 volt divided by RL, this is the resistance of the loudspeaker. So this is the maximum possible current, and the sine power is the half of the supply voltage minus the voltage that the amplifier needs squared divided by 2 times the loudspeaker resistance. Okay, and now comes the improvement. For the improvement I'm using one amplifier for the upper halfway, for the upper part of my sine wave, and the second amplifier for the down part of my sine wave. For example, if I'm putting in here this sine wave, I'm using this self-created circuit for creating a phase shift. So I have here no phase shift and here 180-degree phase shift. So if the upper wave comes into this amplifier, the downside of the wave comes into this amplifier. So this amplifier is pulling up and this amplifier here is pulling down. So we are doubling up the voltage. So in fact we have the doubled voltage across here and here, and if I have here half the supply voltage and here half the supply voltage, and we're doubling that up, we get back our supply voltage. So we have the whole supply voltage from here to there in a bridged version of an amplifier. So if I'm putting that into my equation here, then I get the half supply voltage from each amplifier, but times 2 because I have two amplifiers, so I get the whole supply voltage minus the voltage that the amplifier needs times 2 because I have two amplifiers. So I get nearly the whole supply voltage divided by the resistance of the loudspeaker. And this equals that, and now I'm doubling the current. And for the power, I'm using also the half of my supply voltage times 2, so I'm getting the whole supply voltage minus the voltage that the amplifier needs divided by 2 times RL, and this is 4 times the power that is coming out from the non-bridged version. So I get the 4 times of the power of a non-bridged version with a bridged amplifier. So this is a really good, a really big improvement. Okay, and now I'm showing you how I have built this on the spreadboard and on a schematic. So now we are here back at the spreadboard. On this I have built my second amplifier. Here I've built my first amplifier, so these two circuits are completely identical. And here I have built my phase shift stage, and I've also built a little preamplifier. And now I'm showing you the circuit on the computer. Yes, I'm using Windows XP Professional. Okay, this is just one amplifier circuit. I've explained it in my previous video, so if you want to have an explanation of this circuit, watch my previous video, my part 1 video. And this is the bridged version of my circuit. Okay, in fact I have built this amplifier 2 times. You can see it here, one and the second one. Just one change, the preamplifier at the input has this 100 ohm resistor here, that the amplification of this is not too high because of noise and such things. Also at this preamplifier. And here I have my phase shift stage. First I have another preamplifier. You also have to connect the potentiometer here that you can control the input level, because if the input level is too high, then you get then your waveform gets clipped. And here I have my phase shift stage, which is acting like a common emitter amplifier and an emitter follower. You have the common emitter amplifier is here, and here I have my emitter follower. So I have no phase shift from here to there, and I have also no phase and I have a phase shift of 180 degree from here to there. Okay, for the values, these two resistors must have the same value, and you can select the current over these resistors. On each of these resistors, these resistors must have a voltage drop of the supply voltage divided by 4, and the rest resistors you can calculate if you have supply voltage divided by 4 and then the voltage drop on this diode, and then you get these resistors. Yes. And the current, really important, the current that is coming in here is this current that is flowing down here divided by the B of the transistor. So if the B is 100 and this current is 10 milliamps, then the current that is coming in here is 100 microamps. And the current that must flow down here is this current times 10, so in this case 1 milliamp. Okay, and the next things are really similar to the other circuit. You can see here the preamplifier and then the rest of the circuit, but important, at the end of the circuit, here I have my loudspeaker not connected against ground. I have connected it between these two amplifiers. In this case I don't need these two capacitors, because the voltage from here, this voltage is 6 volt and this voltage is 6 volt, so the difference is 0 volts. So I don't need these two capacitors. I have just put it in if I want to use that circuit in a non-bridged application. Here you can see the input signal, and here you can see the phase shift signal and the non-phase shift signal. Okay, now I'm looking up some waveforms of this circuit on my oscilloscope. For this I'm connecting again this load resistor here. This load resistor has 3.3 ohms, and so I can using it for loading my circuit without having some squeaking sounds with the loudspeaker if I'm connecting my my function generator on this. And now I'm connecting my circuit. This is the output of the first amplifier. I've connected the load here, and I'm also connecting the second crocodile clip on the output of the second amplifier. Okay, so first amplifier output, second amplifier output between the load, and here I have connected my two oscilloscope probes. And now let's look to the oscilloscope. Now we are looking to the output of my amplifier with the oscilloscope. I have connected the first channel to the first output, or to the first amplifier, and the second channel to the second amplifier. So I switch it in 2-channel mode, and I switch on my function generator and my power supply. And now you can see the first channel is the non-shifted, non-phase shifted version. Well, no, sorry, the second channel. This is the non-phase shifted version, and here I have my phase shifted version. And you can see, if I'm putting it the first over the second, then you can see they are at exactly the same level. So if I putting that down and that here, if I invert the second channel so that it is back inverted, so I have both channels at the same phase, then I can put one over the other and they are absolutely the same. So this is really important, that they absolutely at the same level. If I go in XY mode, you can see that now I have no phase shift because of the inversion, and if I have switch the inversion off, then you can see here I have 180-degree phase shift. Maybe I'm making another video about Lisa-Yush's betas, that you can see how this works. If you want that I'm making a video about that, then just write me a comment and I'm doing it. Okay, now I go back into the normal mode and you can see the phase shift again. Now the oscilloscope is connected from these outputs against ground, and now I'm connecting it one output and the other output I'm connecting the ground of my oscilloscope. This is just possible if I have earth isolated power supply, and I have an earth isolated power supply, so I can do that. One moment. So now I'm looking at the signal from the output of the first against the output of the second, and now you can see the waveform has the doubled height. To prove this, I can go into storage mode, and I'm putting the waveform down here, and now I'm saving this waveform as a reference. Save reference 1. So now I've saved this waveform, and now I'm connecting it from the output against ground again. So one moment. So I have connected now the output against ground of the first amplifier on the first channel of my oscilloscope at the same volts per division setting that the second channel I have set it. And if I'm putting it over the other waveform, you can see it is completely doubled. So I get the double voltage, the double current, and 4 times of the power. Okay, now let's look if it can drive a loudspeaker. So now I have connected a loudspeaker on the output of my amplifier. This amplifier against this amplifier connected to the loudspeaker, and now I switch on my function generator. Because of the 4 times power, it gets much louder than just one amplifier.
Music non-stop. Music non-stop.
So that's it for my self-made audio amplifier in the bridged version. I can say thanks for watching and see you again soon.